All right, let's go ahead and graph the last one. So we learned how to graph sines, cosines. Now we're going to go ahead and graph tangent. This is all about your trigonometry section, so we're going to come to the end of it. Here, to graph tangents, I have the steps. They are slightly different than the sine and cosine, because remember, tangent is sine divided by cosine. So here we have y is equal to tangent x, or tangent, y is equal to a tangent bx. A is considered the asymptote, so minimum maximum, but we're not going to focus it on minimum maximum. B is considered the period, so how it affects it. And then here is what typically a tangent graph looks like, right here. So it's kind of like a slant, it's like a long, weird type of S type of movement. Also, your cycle, instead of a normal cycle from 0 to 2 radians, meaning 0 to 360 degrees, it's from negative 90 degrees to positive 90, or negative radians over 2 to positive radians over 2. And that's one typical cycle of it. Here are the steps for it. To find your period, it's radians divided by b. B is the number in front of the x after the tangent, so where I have it there. Your asymptotes, meaning from the start to end. You'll see these dotted lines. Those dotted lines are considered your asymptotes. Third one, you divide the asymptotes into two parts, so you have your measurements there. And the fourth one, this is what you're going to graph with. So you have your measurement here, that's why I have a theta there. That means whatever you get here, that's your first measurement for your negative, comma negative A. A is considered your asymptotes, or sorry, your amplitude. So your amplitude is that number in front, that's why we don't really deal with it until the very end. So let's say if it's 1, so it'll be whatever this is, comma negative 1, 0, 0. So you're always going to intersect at that 0, 0. And then your positive 1, so your second number here, it's going to be your positive, what do you call it, amplitude, which is a number in front of tangent, which is a positive 1. So you have your negative 1 and your positive 1, and then you'll graph accordingly. So let's go ahead and do number 1. Example is y equals 5 tangent x. Here, it's radians divided by b to find your period. Again, if you don't like any of these, you can convert everything to degree form, meaning like 30, 60, 90s. All you do is put 180 in place of radians. So 180 for radians. So like for this one, negative radians over 2. So negative 180 divided by 2, you'll get negative 90. So that's if you don't like the radians form. Here we have radians over b. So in this case, b is the number in front of x, which is just 1. So that means our period is radians, meaning the period is from 180 degrees altogether. So it's not two radians anymore. Second is 2 times your b. Again, b is 1. So that means your asymptotes is between radians over 2 to radians over 2. So negative radians over 2 to positive radians over 2. That's going to be your outside number. I always do 2 lines on the left side, 2 lines on the right side, and that shows you your asymptotes. So negative radians over 2 and positive radians over 2. I'm going to have a dotted line, and that is our asymptotes. Next one, we divide those asymptotes into 2 parts. So negative radians over 2 times 1/2, I get negative radians over 4. That's going to be right here, negative radians over 4. I do the same thing with the positive radians. So radians over 2 times 1/2 is positive radians over 2. Or sorry, positive radians over 4. 2 times 2 is 4. And then you have that. Last step is you have your negative A, you have your 0, 0, and then you have your positive A. 0, 0 is just automatically 0, 0. Your negative A, for this, consider this like the negative side, so you use the first one here. So we're going to use negative radians over 4, and we're going to do comma, and we're going to do our negative amplitude. Going to the beginning, our amplitude is 5, so negative 5 is what we'll put here. Middle is 0, 0, and then here we're going to use our positive one, so we're going to use the positive radians over 4, and we're going to use our positive amplitude, which is positive 5. So if it's negative 5, just think of negative 5, meaning it will be positive, so it'll be facing the opposite direction, but in this case it's positive. Now, let's go ahead and graph it. Negative radians over 4 and negative 5, so that would be about right here. 0, 0 is right here. And then positive radians over 4, and then positive 5 is about here. When you draw as close as you can to the asymptotes. I draw really bad lines. That's very bad. But you get a line that looks something like that. So it's curved and goes down right there. So, yeah, I don't know why I can't draw it well. But it's kind of like thin. And now let's go ahead and do example 2. So now we have a couple things going on. Our amplitude is 1/2. Our period is not being affected, but now it's adding 5. Remember, this is considered a vertical shift, meaning you're moving up or down. So remember that plus k meaning you're moving number of units up or number of units down. So we're going to deal with this, but in the very last step here. First thing we do, we find our period. So radians divided by b. B is considered 1. There's no number in front of the x. So you get radians is your period. Next thing, we're going to find our asymptotes. So it's negative radians over 2 times your b. And that's considered 1 again. So that means your answer is negative radians over 2 to positive radians over 2. Our asymptotes is those two numbers there. So negative radians over 2 and then positive radians over 2. So we have that right here. Third step, divide each of those parts into 2. So negative radians over 2 times 1/2, again negative radians over 4. 1/2 times positive radians over 2, you get positive radians over 4. And now let's go ahead and add it in here. So now we have our negative, this is considered a negative side, so negative radians over 4. And then we have our asymptotes. Our amplitude is considered negative 1/2. But now we have plus or minus k, so we have a number that's being added to or subtracting into it. Whenever you have that number being added or subtracting into the whole function, you have to add it here. So it's negative 1/2, because remember it's a negative 8, but then you have to add 5. The reason why we add 5 is because it's a positive, so we're going to be adding 5 for, I would say it's called a negative coordinate. So I would add 5 here, and then whatever this is, I would add 5 here. So this marker is running out, but I think you can see it. So I'm going to be adding 5 to each of the y coordinate because of my shift right there. So now let's go ahead and find this, a negative radians over 4, and then my negative 1/2 because it's a negative 8, and I'm adding that positive 5. Here it's 0, so I'm not doing anything there, it's still 0. And then here's my positive a, so I'm using my positive function there, so radians over 4, and then my positive a, my amplitude was 1/2, so 1/2 plus 5. Now I go ahead and simplify even more. So this is example 2. I'm going to have negative radians over 4, comma 4.5. So I'm not going to make it into a decimal, I'm just going to put 4.5. And then my second coordinate is 0, comma 5. So now it's not 0, 0 anymore, it shifted up 5 units, and that's how the graph is being displayed. Last one is radians over 4, comma 5. 1/2 plus 5 is 5 and 1/2. So now let's go ahead and graph it. Here, negative radians over 4. Forgot to graph this part. This is positive radians over 4. So negative radians over 4 and 4.5, 2, 4. This is 5. I would say 4.5 is like right here. 0, 5, 2, 4, 5 is exactly right here. And this one is 5.5. This would be like about right here. So this asymptotes is very, very close. And it's always going to go right next to the lines, the dotted lines there. It's not going to go on top of the lines. And that's your one period there. Last one, y equals tangent 2x minus 3. So now the period is being affected. So we have that 2 there. There you go. So let's go ahead and find our functions here. So remember, it's our radians divided by b. Our b is now 2, which is just radians over 2. So now it's changed just a bit. And let's do 2. So remember, it's negative radians over 2 times b. Now we got 2 times 2, the 2 times 2. So now my new asymptotes is negative radians over 4 to positive radians over 4. So always draw 2 lines to the left side, 2 lines to the right side. My left side, negative radians over 4, positive radians over 4, asymptotes. Third step, divide those 2 in half. So let's go ahead and do 1/2 times negative radians over 4 and 1/2 times positive radians over 4. And you'll get negative radians over 8 and positive radians over 8. So 2 times 4 is considered 8, and that makes it a little bit wider and smaller in a way. Now let's go ahead and find our coordinate here. So remember, it's our negative coordinate, so negative 8, negative radians over 8. Our amplitude here is considered 1, so I'm going to have a negative 1. And then I want to see if there's anything adding or subtracting into that function. In this case, there is -3. So instead of adding 5 like this one, we're going to be subtracting 3 to every y coordinate here. So 0, -3 for our y coordinate. And then I have my positive 1, so it's positive radians over 8. I think 180 divided by 8 is like 22 point something. So if you want to put in decimal form. So positive radians over 8, and then I have my positive amplitude, which is 1, but then I'm subtracting 3 from it. So now, when I simplify, I have negative radians over 8, comma, negative 4, 0, comma, negative 3, and I have radians over 8, comma, negative 2. So 1, 2, 3, 1, 2, 3, 4. So now I have negative radians over 8. I'm going to have that here, positive radians over 8 here. Negative radians over 8 here, negative 4, that's my first dot. 0, 3, that's my second dot. And then positive radians over 8, 2, it's going to be my third dot. So when I have my line, it's going to be drawn something to that effect. So you're going step by step. You can create more if you want to. 4. Remember, it's a pattern, so you're going to do the same thing as you did before. So it's going to be a negative 3, this is a negative 4, this is a negative 2. And you create a graph like that, and it goes on forever and ever and ever, but the period is between negative radians over 4 and positive radians over 4. If you need any more help, make sure to email me down there. I will have another assignment where you have to graph these, because you have to practice these. It's not just identifying it, it's practicing and practicing. May see you guys a lot. Bye-bye.